So for this problem, basically the goal is to make two separate functions in terms of theta, and one is to represent the shear stress, and the other is the normal stress. Um, so we can start with a free body diagram to make things a little more simple. So with our free body diagram, we can use our equilibrium equations in y and x to solve for n and v. So n, our normal force, is equal to p sine theta, and v, our shear force, is equal to p cosine theta. And then moving forward, we can determine the area of the triangle, or its hypotenuse, and that can be determined by the angle theta, and the side A. So finding the hypotenuse, we'll have h sine theta equals A, and then solving for h will give us h equals A over sine theta. So here, h represents the cross-sectional area that the normal and shear stress are acting over. And we can represent shear stress as, or we can represent normal stress as sigma equals n over h. And from here we can plug in for n, which was p sine theta. And then we can plug in our h, which is a over sine theta. And that turns out to be p sine squared theta over a. Now doing the same thing for our shear stress, we have tau is equal to v over h. Plugging in our v, we have p cosine theta, and then plugging in our h, we have a over sine theta. And that works out to be p cosine theta sine theta over a. And we can graph those two functions from 0 to 90 degrees. And it will produce these two graphs. And as you can see, our normal stress is a linear function, and our shear stress is parabolic. And maximum normal stress occurs at 90 degrees, maximum shear stress is at 45 degrees. Any questions?